Okay, let's look at problem 60. This is from chapter 2 of OpenStack's University Physics. We have two boats pulling a larger boat, a barge, and we are given the force vectors of each one, and so we're going to find the resultant force. Alright, so I will call this boat 1 and this is boat 2. What's important to remember here is that we're going to decompose each vector into its y and x components. Now the components that work together will end up adding up, and the components that are opposite to each other will end up canceling out. If not completely, they will cancel out partially. Alright, so from boat 1, I have that the y component, I'll do the x component first, and I'll just call it vector 1. Vector 1 is going to be the magnitude, 5,000, and the x component is going to be the sine of this angle. So sine is opposite over hypotenuse. So if the sine of theta is equal to the opposite side over the hypotenuse, then I can solve for the opposite side, which in this case would be my x component, by simply multiplying the hypotenuse times the sine of theta. So that's why I had the 5,000 here, and all I need to multiply then is times the sine of theta, and that is the x component of vector 1. Now its y component is going to be something similar. Again, I'm going to have the magnitude, 5,000, times a trigonometric function. As you may recall, the cosine of theta would be the adjacent side over the hypotenuse. So if the cosine of theta is equal to the adjacent side over the hypotenuse, then the adjacent side is simply the hypotenuse times the cosine of theta. So my y component is going to be my hypotenuse, 5,000, times cosine of theta, and thus my y component of vector 1. Similarly then for vector 2, is going to be the x component, which is going to be 4,000, the magnitude, times the sine of theta 2. And the y component is going to be 4,000 times the cosine of theta 2. Now there's one more thing that you want to realize here, is that the x components will be positive or negative, not depending on the sine and cosine, but depending on the way you set up your coordinate system. So if I'm using this coordinate system, where this is positive y and this is positive x, then the component of vector 1 would be in the negative x direction. So I would need a negative sign right there. And that goes to what I was saying before, that the components along the x direction are in opposite directions. So when we add the vectors b1 and b2, the x part is going to cancel out, if not completely, at least partially. Alright, so my resultant vector is going to be b1 plus b2. So my resultant vector will be a negative 5,000 sine of theta 1 plus 5,000 cosine of theta 1 plus 4,000 sine of theta 2 and then plus 4,000 cosine of theta 2. Here my x hat components are adding and my y hat components are added. We'll have to put that in the calculator. Let's see how much that is. I have a calculator here. Is equal to 1035.276 minus 1039 0.558, and that's in the x direction. That's these two added together. And I'm going to add the other two for the y component. Which I'll write here. Okay, so now I just add those two numbers. For my x component, (1035.276) minus 1039.558 as a negative 4.282 in the x direction, plus 4890.738 plus 3863.703, which gives me 8754.441 in the y direction. Now it looks like my least number of significant figures is 1, so I would want to rewrite this answer in one significant figure. So we see then that because this number in the y is so much larger than this number in the x, my resultant vector will be almost right along the line AV. We could find exactly the angle by just taking the inverse tangent. Now the problem asked for the magnitude. So for the magnitude, you would use the Pythagorean theorem, which would mean that you take the square of the x component plus the square of the y component and then take the square root. As you can see, the y component is so large that adding this small component here is not going to make a difference. So even without making much of a calculation, you'll know that the magnitude of the resultant force would end up being this. Okay, that's it for this one.